So hello everyone. So welcome back to my channel. So hope you all are doing well. So in this video, we are going to fine tune a model, and the model name is function Gemma, and we are going to see how this model is actually working before doing the fine tuning. After doing the fine tuning. So we are going to pick the model from the Hugging Face, and we are going to fine tune the model. And this is a small language model, and it's only 270 million parameter model. So you can easily fine tune this model using the free Google Colab GPU. So I will show you how to do the fine tuning. I will also give you all the code artifacts, and will also tell you how the things are working before doing the fine tuning, after doing the fine tuning, because we know that the the industry is moving towards the agentic AI. And what if we talk about the small language models are getting popular day by day, and if we want to use the small language models, we know that accuracy is low because they have not fine tuned on large data sets. So for your specific problem, for a specific use case, you don't need large language model every time, because due to compliance, due to security and all the things. The second thing is costing, inferencing, and all the things. So what you can do for a use case, you can have your small language model, and that is fine tuned on your task, and it can do the things very easily. And it's also deployed on your system, so you can also tackle the cost as well. You can also secure with your data and all the privacy and all the compliance within your company. So moving forward by 2030, what I can think, the market is going toward the agentic AI, and the small language models are going to be the key, playing a key role in this industry transformation. So now let's start the video, and I will show you what are all the fine tuning technique that exist, and we will go with one of the fine tuning technique to fine tune this model. So yeah, let's start. Okay, so this is our model, and the model name is function Gemma, 270 million parameter, and this is from Google. So if you go to Hugging Face and type function Gemma, so you will land onto this page. So this is our model, and this is specifically developed by Google for a function calling. So we will pick this model and we will fine tune this model on our data set. Before moving on to into the fine tuning, let me show you what kind of task we are going to fine tune it. So I have already written a blog on that. So we will fine tune this model on multi-agent routing task. So what it will have. So user will ask a question, and on the basis of user question, it will identify, okay, for what type of question it is question for technical support, or it's a billing agent question, or it's a product info question. So on the basis of user question, it will route the particular query to a specific agent. So this is our task. So we will create a function, three function, and on the basis of user query, I will fine tune our model, that is function Gamma, and it will route to the specific agent. So this is our multi-agent routing thing. So this is the blog that I have already written, and it's consist of everything, every detail, what this model about, and why the fine tuning is future, for future, what are all the techniques, why the fine tuning is required, and what is its advantage. And I will also mention some of the specific use case regarding the function Gamma that you can use. So this is a blog, and in the below the blog I have also detailed everything, how the data is prepared, and how the agentage we define everything in this blog. And at the last you will get you will also get the code code link, my model that I have deployed on the Hugging Face. You can also see the data set and see the base model. So I will attach this Medium link also in the YouTube description, so you can get into that. So before moving into the fine tuning, let's try to understand what are all the fine tuning technique that we have. So if we talk about a big picture, so there is a two things. There is uh, if you talk about, there is a two axis, axis one and axis two. If we talk about axis one, how you are teaching your model, because every LLM has some certain number of parameter, and we need to update. If what we are doing, if we are doing the fine tuning, we are somehow updating the weights of the pre-trained model that we have. So how the model weight should be updated, what we are teaching, in it what manner we are teaching, so we can have this kind of technique like continued pre-training, we can have supervised fine tuning, we can have a instruction tuning, it's a subset of supervised fine tuning. We can also have a preference alignment, and there we have multiple technique, RLHF, DPO, ORPO. So what we are teaching, how we are teaching. But if we talk about, okay, now we have how the weights are updated. Are you going to update all the weights? So if you are going to update all the weights, then it's a full fine tuning. You are updating all the weights. Now we know that LLM or small language models have, if you want to update all the weights, you need resource. But it may be also possible that you don't want to play with the all the weights of the LLM. You just want to play with the uh some of the layers of the LLM. You don't want to touch the initial layer or middle layer. You just want to do some fine tuning on the output layer. You want your model to behave in a certain manner that it will give the answer in a certain manner for your company. So you are changing the output tone. You are not changing everything that LLM has already learned. Like if you talk about us in a simple term, in the first layer, the LLM is trying to understand what are all the vocab. In the middle layer, the LLM is trying to understand what are all the semantic things. And if you talk about the last layer, it's mostly responsible for the output, how we are getting the output from the model. So that is the thing. So if you want to do a parameter efficient kind of things, you are not going to update all the weights of the model. So you can go with this parameter efficient fine tuning technique. And we have this very famous technique, LoRa, QLoRa, DORA, adapters, prefix, and prompt tuning. So these are all the techniques. So in this video, as we know that our model is very small number of parameter. It's only having a 270 million parameter. So we can easily do the full fine tuning on this model using a Google Colab free GPU. So what we are doing, we are from the axis one, we will pick instruction fine tuning. I will prepare some instruction data set, and I will go with the full fine tuning. So yeah, so let's move to the Google Colab, and I will show you step by step things how you can do the fine tuning, and I will also show you uh, what is the accuracy of model before fine tuning and what is the accuracy of model after fine tuning. So yep, so let's move to the Google Colab, and this is our Google Colab. So go to this runtime setting and select T4 GPU. So yeah, now the GPU is been connected. So let's install the dependency. So you can also install the flash attention, but if you have your paid one GPU, but I will just comment this flash attention because we generally do not require this for if you are running this fine tuning on the free GPU. So I will comment this flash attention, and I will start installing. So now our runtime is connecting and it will install these packages. So now the package installation has been done. So now let's log into Hugging Face. So because we will download this model from the Hugging Face. So what for that, what you have to do, you have to authenticate with your Hugging Face token. So you can create a Hugging Face token by visiting to the Hugging Face site. So I have pasted token and I will log in to the Hugging Face, because to download this model, you need to be authenticated by Hugging Face. Okay. So after that, what I will do, I will define my base model and my checkpoint directory for this, like where all my uh, intermediate step will be saved. So this is a function Gemma calling router, and this is the base model. So let me run this. So they are all the library that we have already installed, and now we are importing all the library. So after that, let me create a data set. Let me give you the overview of the data set. So you can see this is the multi-agent data set, and you can see we have this uh, user content. This is our question, and on the basis of what will be my answer, and what is the argument. Like if the user is asking this question, so we will go for technical support agent, and what is the argument that will it is issue type crash and priority is high. So we have two things in the output, like what is the actual name of the model, what is the correct name of the model, and what is the actual parameter with the help of which we will call that function. So this is the example that we have prepared for technical support agent, billing agent, product information agent, and we have some mix variant of all the three agents. So we can see. So this is our data set. So if we look into it, so we have 115 training example, and in that we have 39 technical support agent, 39 billing agent, and 37 product info agent. So this is our data set for this fine tuning. Now let me quickly define the tools or functions. So you can see we have now these three tools definition. The first one is technical support, and this is the argument. The second is the billing agent, and we have this argument request and urgency. And the third one is product info agent. We have this query and the category. So this is the three function, three agent tool definition that we have. Okay. Now just quickly convert this into a tool. So we will use this uh, get JSON schema, and we are passing our function to this, and now our three tools are available in this variable. Just quickly define a system prompt. So what we will do, we will create the conversation. So you can see this is our system prompt. With the help of that, we will do the fine tuning. You are an intelligent routing agent, and that direct customer query to the appropriate specialized agent based on the nature of this request. So you can see we have defined our system prompt, and we are creating a conversation using our three tool that we have defined. So system message and assistant message. So this is our default prompt, and this is our user query, and this is our assistant response. Okay, with the help of what is the function and what is the argument of that function. So yeah, so we are creating a conversation to do the fine tuning. Okay, after that, what we will do, we will just use the dataset library. So this is our dataset library that we have we need to convert this our dataset conversion using this dataset library. So what we will do, we will use this create conversion function conversation function, and we need to map this in a particular format for doing the fine tuning. So we are taking all our dataset. After that, what we are doing, we are creating a conversation for the dataset, and now we are splitting that dataset into a training and testing. So we will fine tune our model on this 92 dataset, and we will validate our model on this 23 sample example. So now let's load the model and tokenizer. So now what I'm doing, we have already defined our base model, and now we are actually loading our we load our model. So now our model is being loaded from the Hugging Face. Now we can see our model is start loading. So let's wait for model to be loaded. So you can see. So this is a very small model, so it can be quickly loaded. It will not take too much time. Okay, so we can see it's taken 21 seconds, and now our model has been loaded. Okay, now the first thing is we have to do, we have to test this model, what is the accuracy of model before doing the fine tuning. So we'll try to test this model, what is the actual accuracy of the model before doing the fine tuning. So let me for doing this, let me create a function, and that will help us to uh, do the testing of your model. So the first thing is that when the model will generate a response, we have to extract, okay, what is the function call the model has done. So for that, we have created a helper function, utility function. So what it will do, it will try to extract the function name and its argument from the model response. So you can see we will search this pattern, start function call and end function call, and we will try to extract the data from the model response, because model will respond in a certain manner. So we'll try to extract the things from the model response. So this is one helper function. And the second helper function will be to score, to give the score. Now we can see evaluate routing. So we will use that function, the first function in this function, like you can see start function call. And on the basis of that, this function will do the scoring, whether the response is correct or not, whether the function calling is correct or not with the correct argument. So this is the second function, evaluate routing. So let me quickly run this function. Okay, now we have our both the function ready. Now let's start testing the model. What is the accuracy of model before doing the fine tuning? So evaluating the model before doing the fine tuning. So let me start the evaluation. So we are testing the 23 sample example, and you can see for the first question, how do I connect your REST API to a Node.js? So you can see expected output is technical support agent with this parameter, but model is not responding anything. You can see. So because this model is developed by Google, and that model don't have any idea about what are all the agent that we have, what are all the tool definition that we have. So it is not knowing about our dataset, though on the basis of the prompt, it will not work. So you can see the only it can able to give the correct answer for this. Like, does the enterprise plan include dedicated customer support? So it can able to identify the correct agent, and it can also identify what are all the correct parameter. So if we talk about the accuracy, so we can see our base LLM that is provided by the Google, it can able to just give one correct answer of all the samples from all the 23 examples. So yeah, so this is the accuracy before doing the fine tuning. Now the stage is set to do the fine tuning. So now what we will do in the next step, we will define our fine tuning configuration. As we have discussed, we will go with the supervised fine tuning like STF config. And what we will do, we will do our fine tuning, full fine tuning. So what we are doing, they are all the parameter that is defined. So this parameter may be changed according to your use case, according to your complexity of data and all the things. So I have tried multiple times, and this is the best parameter for this use case. So yeah, so you can play with the parameter, and you can also uh, do the experiment multiple times, and after that you will have your best parameter for doing the fine tuning. So yeah. So if you want to push to if you want to push this thing to the Hugging Face, you can just put your Hugging Face token and the Hugging Face repo name, and your model will be automatically pushed to the Hugging Face. So let me also define this. So let me define the Hugging Face token, and you can also do this thing. So if I just quickly define the Hugging Face token here, so you can use your own token. And let me also define this Hugging Face repo name. So yeah. Okay, so I have defined my Hugging Face token and also my Hugging Face token and Hugging Face repo name. So I will just mark it as YouTube demo, YouTube, YouTube demo. So yeah, so it will automatically push our model, fine-tune model to the Hugging Face. So let me run this, and we have already defined the configuration. So yeah, so now our configuration is ready. So after that, what we need to do, we need to start the fine tuning. So for that, let me initialize the trainer, and we will start the fine tuning. So now after that, This is the initialization of STF trainer, and we have our test data and we have our train data, and we have already defined our the training argument. So now the initialization is been happening on our testing and training data. Now after that, what we need to do, we need to start the training. So now to start the training, we will use this object and we will go with the trainer.train. And we will also save the model after the training has been completed. So let me start the training. So it will depend on the basis of your training size, what are all the batch size you are using. So the training time will totally depend on this configuration, and also on your problem statement and how many data set, what is the size of your data set, what is the complexity and all the things. So for this, I think it will take around 15 minute approx. So I will start the fine tuning, and we will see what is the result that we have after doing the fine tuning. So let me start the fine tuning. So, okay, so we can see our training is completed, and we can see the training loss and validation loss for all our 15 epoch. So we have configured 15 epoch, so we can able to see what is our training and validation loss. And we can also see our GPU usage. So it's almost around our 15 GB, because the model fine tuning is happening in the background. So we can see our GPU usage also very large. So it has taken around 17 minutes to do the fine tuning. And now we can let me create a plot for this training and validation loss, so we can quickly observe this. So let me show you. So, so yeah, so we can see our both the training loss and validation loss is decreasing according as we are moving towards our epoch, as we our epoch is continuing. So this is a good sign. It's a perfect fine tuning things. And if in your if any scenario, if your training loss or validation loss started increasing, so now you need to stop your fine tuning and you need to play with your parameter. So let's suppose if your training loss is somewhere after certain interval of time, if your training loss started increasing, so now you should stop your fine tuning, and you need to check your, okay, what is your data set, is correct or not. What is your epoch, what is the batch size you are configuring, what is the learning rate you are using. So you need to play with this kind of parameter. And if your validation loss is increasing, so it's means your model is now overfitting. So now you need to play with your parameter also. In that scenario, you need to stop, you need to create a diverse set of example in your training data and also in the testing data. So but in our case, both training loss and testing loss are decreasing as we are as our epoch is increasing. So it's a good sign for our fine tuning. So yeah, so now our model uh, is being fine tuned. Now let's test the what is the accuracy of model after doing the fine tuning for the 23 example that we have done before the fine tuning. Okay, so now we are evaluating on the 23 sample. Okay, the first one is wrong, but we can see the second one, it can able to identify the correct. If you go for the fourth one, also it's giving the correct answer, identifying the correct agent with the correct parameter. So we can clearly see after doing a 15 to 17 minute of approx fine tuning, we can able to get the correct results in our testing example. So yeah, we are having some incorrect answer, but it's totally depend on the training on the internal training and testing on the parameter that you have configured on the while doing the fine tuning, what kind of data set you have. But you can clearly see we have around 16% of accuracy. Earlier we have only 4% of accuracy. Yeah. So certainly our accuracy has been increased from 4 to 60 after doing a small amount of fine tuning. So we can see this fine tuning is working. And if I just create some data also, like we are going to see, okay, what is the actual thing that is happening. So let me define our learning rate. So let me create some more plot so we can able to visualize what is actually happening. So let me use my learning rate. So what we have configured, so the learning rate is 1 24 5. So let me initialize that. Okay. So after that, what we will do, we will just save this all the artifacts in the JSON format. So let me go for importers. Okay, so we can see before doing the fine tuning, we have uh, only one correct answer, but after doing the fine tuning, we have around 14 correct answers. So there is a 13 improvement and there is a 56% improvement. So you can play with your with the parameter. For our use case, if we go to our training and validation loss. So we can clearly able to see that our ideal epoch will be around if we go we can have 10 epoch for this data set, because after that we are some seeing slightly increase in the training loss, and also in the we can also see there is slightly so there is nothing happening on the validation loss. So for this data set, if we also pick epoch as 10, so it will be the good for a use good for our use case. So you can play with this parameter or the parameter that we have defined here. What is the epoch, what is the batch size, to do the regularization, you can play with this weight decay, warm up ratio. So yeah, these are all the things that you can play to improve your fine tuning and to improve your accuracy. So yeah, we can see after doing the fine tuning, we have this great improvement in our result. So yeah, so this is from this video. So I hope so what I will do, I will attach all the artifacts in our description. So on this Medium blog link that I have shown you, and in that you have your GitHub repo link also, and my model on the Hugging Face. So if you go to this, I have also I've also deployed my model on the Hugging Face. So you can go and you can use this code and you can do the inferencing with the help of this code. So I have also deployed this on the Hugging Face, and the data set is also available on the Hugging Face. So you can go and use this. So yeah. So thank you for watching this video, and have some questions, so feel free to comment and I will respond to you accordingly. Do subscribe to my channel, and I will keep posting the video regarding the fine tuning in the upcoming days regarding the multiple using different use cases regarding different use cases using different LLMs. And